Have you ever just looked up at the night sky and felt that thrill of discovery? The universe is always throwing surprises our way, and today we're doing a deep dive into one of those. We're looking at the latest on Asteroid 2024 YR4. We've got some really fascinating new observations from the James Webb Space Telescope to unpack. Think of this as your fast track to understanding what's really going on out there in our cosmic neighborhood.
Yeah, it's quite interesting. What's really compelling is how Webb's latest look has really helped refine the projected path for this asteroid.
Refined its path.
Exactly. I mean, when 2024 YR4 was first detected, there was some initial, very brief concern about a potential Earth impact. Very low probability there.
Okay.
But the big news from Webb's data isn't about Earth, actually. It's a subtle but pretty important shift in the probabilities for its future trajectory, specifically regarding the moon.
Okay, that's unexpected. So just to be clear, Earth is definitely safe.
Oh, yes. Confidently in the clear. That's been solidified. But the odds for the moon, they've nudged up slightly.
Right. So can you walk us through how exactly Webb's observations can refine a path with such precision, enough to change those specific odds?
Sure. So just before the asteroid drifted too far out of sight, the Webb telescope managed to grab one last, very detailed observation.
Ah, final glimpse.
Exactly. This was back in May. An international science team used Webb's near-infrared camera, an IR cam. And the data they got, well, it was like gold dust.
Okay.
It gave scientists at NASA's Center for Near-Earth Object Studies, that's at JPL, the Jet Propulsion Laboratory, the information they needed to significantly improve their prediction of where the asteroid will be.
Improve how much?
Specifically, they got about a 20% better estimate of its exact position on December 22, 2032. That's the level of fine-tuning we were talking about.
Wow, okay, 20% better. And that's what led to this probability shift for the moon impact.
That's right. That fine-tuning is the direct cause.
So it's great news for Earth, obviously, but, for those of us quite fond of our moon, what does this shift from, 3.8% to 4.3%? What does that 0.5% chance really mean in practical terms? Is that something we should be concerned about, or is it more about the science?
It's really more about the science and the incredible refinement, even though it seems like a tiny shift numerically.
Yeah, 0.5% sounds small.
It is, but increasing the certainty of the path slightly raised those odds for the moon from 3.8 to 4.3%. What that 0.5% really tells us is just how incredibly precise our ability to predict these paths is becoming.
Right. It validates the methods?
Exactly. It validates our advanced tracking capabilities. It shows why continuous high-resolution observation is just so critical for, properly assessing risks and eventually mitigating them if needed.
Can you give us an analogy, maybe?
Sure. Think of it like trying to predict exactly where a tiny fly will land inside a giant football stadium.
Yeah.
Every little piece of new information about its speed or direction dramatically improves your prediction. That's kind of what Webb did here. And it's really important to add, even if there were a collision with the moon, which is still very unlikely, remember, it absolutely would not affect the moon's orbit around Earth.
Okay, that's a crucial point. Thanks for clarifying that. So Webb gave us this clearer picture, but you mentioned it drifted out of range.
That's correct. Right now, Asteroid 2024, YR4, is actually too far away and too faint to be seen. Not by ground-based telescopes, not even by space telescopes like Webb.
So it's gone dark for now.
For the time being, yes.
Right.
It's slipped out of view. And that really underlines why we constantly need these powerful tools like Webb. It highlights how refining this data is. It's an ongoing process, right? Objects move, windows for observation open and close.
It definitely gives you a fresh perspective on just how dynamic our solar system is, and it kind of leaves you wondering, what's next for 2024 YR4? So what does this all mean for you listening? Well, it shows that our understanding of the universe, it isn't some fixed textbook. It's alive. It's constantly being updated and refined by new data. With 2024 YR4 now out of sight until, I think, 2028, it's not just about waiting. It's a chance to think, isn't it? What new data, what completely fresh insights, maybe even what further surprising refinements will we uncover when this cosmic traveler swings back into our neighborhood? It's just a powerful reminder, I think, that every single observation brings us that little bit closer to truly understanding our place out here among the stars.